I guess that's everybody we get. Do you want to start off then, Alexander? You had an item about pipeline synchronicity.
Yeah, about last week I went deep into benchmarking and profiling ZFS and trying to reach very high throughputs on NVMe pools. And I found we actually had this issue observed for last several months in our perf team. But I think only right now, I found proper explanation of what's really going on. So to describe it, for some time we had some fluctuation performance numbers between releases up and down pretty significantly, and between Linux version. And at some point we found there was some change to task queue code on Linux that made threads not exit so aggressively. But appeared that after that performance dropped significantly, and I had no explanation for that. But now I think I do. Well, how I see now this performance problem is that we have a ZIO pipeline where each ZIO goes through the same set of stages: compression, encryption, checksuming, RAID Z, parity, whatever number of stages. And if we have number of identical blocks going through identically the same pipeline, they have tendency to do it exactly same time. Since our sync threads can now generate like million blocks per second, which blocks every microsecond, and processing of single 1 megabyte block may take 1 or 2 milliseconds, it really means we have 40, 50, 100 CPU cores, first all together doing compression, then all together doing encryption, then all together doing checksumming, memory copy, and so on. The problem at each stage, we are bottlenecked on some of CPU resources, some specific kind, while all other kinds of resources are idle. I was thinking about it for a couple days on and off, but I have no good ideas how exactly to break the synchronicity better. I was thinking about injecting some delays at the beginning of the transaction group, but how big those delays should be, and it's kind of ugly. I'd really like some public ideas on that front. Like, how from one side, I don't want any global locks to do per zero, so it should be some sort of soft lock. But I just don't do all encryption same time. But it doesn't mean don't do encryption at all. You just try to not do it same time. At the very least, we could insert some delays at the beginning of transaction group science. After that, chance they will resynchronize should be pretty low, unless the IOs will be reissued later by completing of previous IOs and allocation throttling or something else. But those could be fixed one at a time. But just doing it once per transaction group would be the cheapest way. But it's also kind of ugliest way. So I wonder if anybody knows any techniques of parallel programming to solve that issue. I know that's definitely mentioned in Intel performance optimization guides, but they mentioned the problem. I don't remember the solution. I may need to go read it through, but it's a huge document. It would take me probably a few days to read it. So I'm open to any good ideas or any ideas at all.
Yeah, like the first kind of naive idea I have is if we just had, if 30 other ZIOs are doing compression right now, we should wait or something. That's kind of doesn't necessarily have to involve a lock, but some cheap way of just a general idea of how many other ones are in a certain stage and trying not to have more than half of all the ZIOs that are executing in any one stage or something. But I don't know that that helps much.
No, on the other side, if we start doing it too often, we may burn significant time on just waits. And from one side or another, if we disable all the features and literally have only checksumming, or will we after that get waiting just because of the only thing we're doing is checksumming?
Yeah, if there's not other work to do, then waiting is just wasting time even. But yeah, like you said, especially with multiple threads and so on, if they're doing different workloads, there's much greater chance that you'll get more out of the same CPU than if they're all trying to do exactly the same thing.
I think it's in that optimization guide explicitly mentioned, if you have hybrid threading cores, the best way to get more of them is make one of them do heavy math, another do IO, or something like that, different kinds of workloads. So they would not compete with each other. And it would be great if we could somehow distribute it there. And to my tests, on my earlier ones, it seems like difference is huge. It can be from 20% to 50% or probably more. It's just so far trying to experiment with it. I'm hitting other issues. But yeah, I expect it to be a big deal.
I don't have any other immediate good ideas on how to deal with it, but it is a good spot and something I think that'll make sense to dig into to see how we can try to smear the work out a little better, and so that it's not kind of going in lockstep like you mentioned. Do you know from the, like, for a certain workload, what the distribution is of the different stages in the pipeline? Like, is checksuming generally the heaviest, or?
No, actually,
only if you don't have encryption, right?
No, yeah, I haven't benchmarked encryption, but heaviest is usually compression.
Right.
But things change dramatically if we are able to combine same time, because when we have everything enabled, then compression is the heaviest, while checksumming and memory copy is pretty much easiest. They're just hiding behind their compression because of cache writebacks. But as soon as I disable compression, memory copies explode the same moment dramatically in times, 3-4 times, just because now system becomes memory bound instead of computation bound.
Right.
So it's difficult to measure, but if we could do it in parallel, then definitely we could improve performance double. I believe like while some cores doing compression, other cores doing memory copying, and so on.
Yeah. What kind of results are you tending to get with even with this bottleneck?
No, with bottleneck, no, depending on the system, in our close to production system, the question was about like 10 gigabytes per second versus 8. Like fluctuation between 8 and 10, like 10 when less synchronicity, 8 with more synchronicity. On my tests, I'm getting numbers between 20 gigabytes and 40 gigabytes per second. Potentially could go in higher. At 40, I bottlenecked by disks I have in the system.
Yeah.
With more and more NVMe pools, numbers like that getting routine.
Yep. Have you done much testing more on the IOPS side rather than the throughput side?
No, IOPS side, it should be in better shape since they have no synchronicity problem. And normally our bottlenecks on IOPS side was no, practically not like called IOPS, but blocks per second side we were issued by the sync threads. But now we have number of sync threads equal to number of allocators, like that is 4. So we should be easily overcome 1 million blocks per second. And after that, we'll get some lock contentions on allocation throttling on a couple other places. Maybe VDF locks. But allocation throttling probably is the worst ones.
Yeah, because that's the stuff we've been looking at lately.
It's actually per allocator too, so it should scale. But yeah, I think we should be able to get close to 1 million. Actually, another thing I'm looking right now, working on this performance problem of large blocks, I found that later patch by Etnodolsky and me to tie allocators to sync threads has downsides that of imperfect balance between task queues. So deep into the sync process, I see that some of task queues are already idle, while others still have a lot of work to do. So I'm right now thinking to maybe rework the distribution to balance, maybe just to more fair between blocks between task queues, so that they could all complete closer to same time. I think maybe sync threads could select new allocator, not just randomly or not, or as it was originally, or bound to task queue, but each time new object needs to be synced, they look, okay, which task queue has less of a queue or had less work previously, let's select one and then
try to balance it better.
Yeah.
Because we're looking at on the read side and two different configurations for different customers and hitting some odd bottlenecks in different places. Everybody's machine is quite different, it turns out. Like in one of them, we're seeing, maybe 250 thousand IOPS, and it doesn't seem to scale as we add more VDEVs. But another machine, like you said, we're easily able to get 10 or 20 gigabytes a second, and the scaling looks like it should. And so still trying to dig into where some of these different bottlenecks are. Okay.
As I thought, sync threads I saw for many years about was 1/3 of a million, maybe 400,000. But now that should be better. After that, we should have debuff cache eviction, arc eviction. I remember you was going to work on
we have
eviction.
A prototype of the concurrent arc eviction working. It cuts the time to export a pool with a full arc by more than half. So it definitely seems to work pretty well. And we're looking at the debuff cache right now. Because on the second machine I'm benchmarking right now, that's definitely the heaviest consumer of CPU is the debuff evict thread. Especially knowing that the debuff evict thread is really dumb and only does one at a time and then starts at the bottom of the list every time instead of doing, just batches of like 50 or 100 or something as it's walking the list, and would be, a lot more efficient about it. Because I don't think most times that you're going to get below the low water mark or whatever you're trying to aim for by evicting one item.
Yeah, sure.
Yeah.
No, debuff cache is not so huge as arc. It's supposed to be small, but one item is probably overkill.
So yeah, that's definitely on other systems, especially with smaller blocks. That's the bottleneck we're seeing. Even to the fact of just you can't read any faster because you can't evict stuff from the arc fast enough to continue reading as fast as the disk can go.
One more issue I was trying to think in process is that while we are writing data, we have to spend time copying data from debuff buffers into arc buffers, from linear into scatter page ones. And that feels like a kind of waste of time. I was thinking ways to overcome that. Obviously, with debuff requiring linear buffers, we have to do that copy, but I was thinking maybe in some case we could decide that maybe that write once, read never data could just skip an arc if we could invent some sort of logic mechanism to just to say this data are uncacheable, don't put them in arc. Then we could save one memory copy. Same applies to compression. If we tried for a couple transaction groups to compress something and it never compresses, maybe we should give up on compression, or like try to compress one block out of 100 to see whether it's still the same.
Yeah, I have Saso Kislikov's prototype of that, where it remembers as in the denote or something for each object, how many of the last so many writes actually compressed, and uses that to only try 1 in 100 blocks if the file has been uncompressible so far. To kind of smart compress, I think it was called. But I think, to your point about the debuff cache, it's like most of the time there's still going to have been the scatter version already in the arc anyway, right? And then we linearized it, and that's how it got in the debuff cache in the first place.
When we are reading, data first read into physical memory to scatter at ABD, but then it's copied into debug cache on read. That's another copy. I was also thinking maybe we could think about non-linearized debuff when application ARC requests VFS read or whatever. Just don't copy data into debuff. Just create debuff pointing to nowhere or to ABD or whatever, and just copy data directly from ARC to user space as a copy or decompress, whatever. If they're not compressed, then just copy directly. If they're compressible, debuff cache obviously may have some benefits to not decompress twice, but if data are not compressible, then why to copy data into debuff at all?
Yeah, well, and there, maybe we can even be smart, and if it's in the MRU, then we don't linearize it, because obviously it's not been read a whole bunch of times. So we only have to worry about decompressing it many times if the ARC buff is in the MFU.
Yeah,
it's in the MRU, we could say this obviously hasn't been accessed a whole bunch of times, so we're okay if we have to decompress it an additional time. And then if we do, that'll move it to the MFU, and we will then know, okay, we will actually linearize it this time.
Yeah, would be good.
Yeah, so just never go to the debuff cache if it's only on the MRU. Does that make sense? It would save a lot of memory copies, wouldn't it?
Yeah. So, if it's compressible, we first doing a copy from scatter gather into linear compressed, then decompress, and then copy to user space. It's another question whether we could do any operations on scatter gather buffer. I briefly looked on the LZ4, and right now it requires linear buffer, but I wonder if it could be. No, we could, but it could modify it to actually work on scatter gather, but then we would diverge from upstream LZ4. I don't know how good is that. Probably not much.
I think Z standard has the stuff to take it chunks at a time like that. I just don't know if when you do that, you end up with the same block on disk as if you fed it a linear one. I think so, as long as we don't change the frame size. But yeah, that would be worth looking at too, I think. And then the other one that was showing up a lot in the top was the null interrupt task queue. I know you had made some changes to that relatively recently.
I skipped ready stage for null ZIOs if it's not required for anything. I think there was actually open PR to revert that from somebody, George or somebody else. I hope it never land, but maybe we could close it if nobody thinks that's big change. I suppose since nobody requested it more for like a year since I committed my patch, it's probably okay for most people, or just people don't care. So yeah, I removed that interrupt for a ready stage. That helped a lot on some ZIO workload or some ZIL workloads.
Is that in 2.2 or is that only in master?
I think it's only in master. I was thinking to merge it, but since there was dispute about whether it's good or not, I decided to not.
Trying to remember how long ago it would have been, if it would have been 2.2 already or not. Because yeah, we were also looking at just the way dispatching happens. We only dispatch if it's the same type, and sometimes it might make sense to like direct dispatch the null interrupt because it most of the time it's just the container of the parent that's this, or it's the parent that contains a bunch of other stuff to do the synchronization, and that not having to context switch and have that run on a different CPU or whatever could save a bunch of delay there as well.
Yeah, maybe we could mark ZIOs to show, depending on how heavy handler do they have. If they have some heavy done functions, then dispatch could make sense. If it's lightweight, maybe you could execute it directly, something like that. Because it may depend on where exactly that null is used. I can easily believe there could be some ZIOs with pretty heavy handlers
Right, that we wouldn't want to do that for. That's a good point. I think next on the agenda, Dexter, you had some thoughts on the OpenZFS conference?
Yes, hello. So I believe some of you were part of a conversation at last year's Developer Summit. And I think we all concluded it was a bit too homemade for full participation, such as having streaming on the second day, etc. So since then, Matt, Karen, and I have been talking along with George and others. And we came up with some conclusions after, you may recall, I polled the group at the last meeting saying, hey, which days work for you? And then they circled that around internally, and we came up with dates. I put them in the chat, and perhaps people have joined since then, so I will copy and paste that back. But to make a long story short, and you heard it here first, we are planning the traditional Monday, Tuesday Developer Summit on October it would be 28th and 29th, and then 2 days, Saturday and Sunday, of what's loosely called at this point production user topics. And that might be unconference, that might be presentations, but we have a time and a venue. So we'll block in those unanswered questions. And of course, that's full new territory. There was once the one or two, I think Datto hosted user conferences.
And there was something in France once or twice, years and years ago.
So those who have participated in those, we as a team welcome your input. If anyone here wants to be involved with that planning, great. If you want to reach out for sponsors, we already have, sounds like 2 lined up, but if your company might want to help out, let us know. We have a very flexible venue, and we can control costs in ways that downtown San Francisco do not allow. So I think we can have a lot of fun with this. The venue hosted Linus Torvalds like 3 weeks ago, so I think we'll do okay. It's a great size for this this type event, and let me know if you have questions, and especially if you want to help out with the planning in any way.
Okay.
That's it. Thank you.
And then the next item was on the fast dedupe stuff. Brian has switched the zap shrinking PR to accepted, so that should get merged soon, I think. So now we're over to the dedupe quota patch. Don, I think you updated that at the end of last week.
Yeah, I was working on I think the prefetch one, and found some tests failing. So I just fixed the tests so they don't fail. They were failing on, I think, Red Hat distros because of where the mount was or something like that. There was some bug in there.
Okay. And so yeah, we need a second reviewer for the dedupe quota work. Alexander Boten has already gone through that quite a bit, but we need a second person so that we can move forward on this. And I guess the same goes for the prefetch one now as well. So the dedupe quota, to quickly recap, allows you to set the maximum size of the dedupe table. So whether that's going to be in memory or on like a dedicated dedupe VDEV or whatever, ensuring that if you hit that quota, it will basically start acting as if dedupe was off. And this allows you to get the benefit of dedupe up to a point where it's going to take too much memory, or especially overflow your dedupe VDEV and start doing IO on your main pool that might be a lot slower than your dedupe VDEV. And so that works that way, and then it gets combined with the next pull request that's will get posted there, which is dedupe prune, which actually allows you to, in the background, as you're approaching that quota, start finding the dedupe blocks that haven't deduped that are looking the least helpful, and be able to remove those from the DDT to make room within the quota to continue to dedupe rather than having to stop when you hit the quota. And so it will cycle out entries that have been on the dedupe table for a long time and not found a partner, to make room for new blocks to continue to be added to dedupe, since they are more likely to find a partner than a block that's been around for months and has not. But it'd be great if someone else could find some time to just look over that code and leave feedback on GitHub. Okay. Were there any other topics that anybody wanted to discuss?
I'll say, every Wednesday afternoon Pacific time, 1 o'clock, there's a production users call. It was fantastic to have you, Alexander, last week to give us updates on all of your work. And it's been a great sounding board for just new features, ideas, pain points, you name it. So for something less structured than this, you are all welcome to attend. I think it's on the wiki somewhere, but if it's not obvious, let's improve that. Okay.
Brian, were you doing some refreshing of the Direct.io stuff recently? Did you want to talk about that?
I mean, it's pretty much up to date on master. I just need to push actually, Alexander, you just did that thing with the debuff read, which I verified, and just need to push again. But yeah, I mean, it's up to date. I think the biggest thing is it just needs reviews.
Yep.
It's kind of the catalyst at this point, right? There's people reviewing it. But yeah, it's kind of where it's at.
I will add it to the agenda here, so anybody who watches this later or something will have a handy link to it.
Yeah, that would be great.
Yeah. And then Alec, I think you recently finished the stuff you were doing with her ZFSD. Do you want to just talk about that briefly?
Yeah, I mean, we've tied up all the loose ends. Basically, the catch lets us use the same VDEV printables for disks to set up the retire threshold and degrade thresholds the same way across different operating systems. So for Linux and FreeBSD, we can now use VDEV props to set those thresholds. And I updated the man page as well to make sure that we know that the actual defaults are different between operating systems. That's
Right, so that's when the VDEV property is not defined.
right, yeah. So the defaults before the VDEV properties are defined anywhere are different.
Are there any other bits of the configuration of the fault management that we think we could elevate to being properties like this, so that you configure it the same between the operating systems?
There's nothing that I can think of off the top of my head, but I definitely know that the behavior of Z and ZFSD differs. So, like for example, Z will not retire a bunch of disks if you have several that are failing at the same time, but ZFSD will. So maybe we want to eventually get to a place where they behave the same way.
Mm-hmm.
But that's not something we've been looking at. It's just one of those things I found or noticed when I was working on this.
Yep. And then nice, Sean Eric. I remember long ago you were looking at, was it trying to commonize the share NFS property between Linux and FreeBSD?
A long time ago. I haven't touched it in a long time because there is no consensus on it. But the idea was to have for properties that could not be shared, but was to have an implicit OS specific one.
Right. So you'd have like share_nfs.linux and share_nfs.freebsd, of which share_nfs
And
is
then
an alias for, and then
exactly aliases was what I called it. No one seemed to particularly need it. So it kind of languished. There's so many things do when there's an idea, but no significant desire. On that, I haven't been working on ZFS too much, but I still use it. So I realized that I should start attending these when I can.
yeah, but maybe bringing it up again, we'll find someone who does have a use case. And was there any other properties that were overly OS specific other than maybe I think we dealt with vol mode differences between Linux and FreeBSD with the geom setting and so on. But are there any other?
There were actually a couple, but I can't remember. I'd have to go look at the branch with the test code I made. But the NFS export, there were a few others as to that were more simple, honestly. The export one was the one that was just, you have to know what OS you're using on. If you import it, it gets confused badly.
Yes, especially I remember looking at it with George Wilson, the Linux NFS exporter. If you include a path that doesn't exist, it will not start. Whereas the FreeBSD mountd will skip the invalid path and at least share the rest of the things in the configuration. And that made a big difference on Linux, like when a pool went away and so the exports file didn't get regenerated or whatever.
About the walls being symmetric, it would be nice that multiple task queue implementation from Linux could be ported to FreeBSD for them to be similar. There's no reason not to do it. FreeBSD also has a direct dispatch mechanism that's now absent on Linux, but at least it also has a normal mode when it decouples through task queue, but right now it uses one task queue per ZVol. Well, there's no reason to not to do the same as done on Linux.
Which is one pool of task queues for all ZVols, but it's bigger?
Have several task queues which are distributed between multiple ZVols. So it tries to find a better of both sides.
Yeah. Have you found much about which workloads work better with direct dispatch versus the kind of deferred to the task queue?
It's all question whether application has own multiple threads or it depends on asynchronous execution by the disks. We found that, for example, Linux SCSI target it's configurable by default. It uses one thread on its side, but depends on multiple threads on a backend side. But it can be configured for direct dispatch on a lower side and then use multiple threads on CST side itself. So it depends. It can be one way or another. Some virtualization, I think, was more could benefit from multiple task queues. Well, in FreeBSD SCSI target, from beginning used multiple threads on side of target itself, so it didn't need multiple, so it used direct dispatch always. It would be nice if we could detect what application can do. With Amir, we were trying to investigate a lot whether we can get anything useful from Linux, like whether it's actually expect to wait on specific IO requests or not. If it sends one request and gonna sleep on it, then sure, let's do direct and save resources. But we found it can happen in all possible ways, and we haven't found a way to do it. any more efficient. Otherwise, yeah, it would be great, but unfortunately.
Yeah, it would be great if the user didn't have to pick, but you know, software doesn't know what it's doing.
Yeah.
Right. Were there any other topics that people wanted to discuss today? I think the only other one, Don, was looks like there was kind of mixed feedback on the JSON zpool status.
Yeah, the most recent comment was we're doing sort of ambulance to JSON in user space and now doing it a different way in the kernel. Perhaps we should unify how we do that.
Yeah, it's Umer from my team is working on JSON outputs from different utilities in user space, and having two libraries in ZFS for JSON output is not exactly great. As far as I know, his approach is to use conversion of NV lists into JSON instead of generating one from scratch. So,
yeah, the thing that the one the pull status was a sort of a hybrid. It built up stuff in NV list because it was convenient. Other stuff it just put in there. So it sounds like there's already an effort to do NV list to JSON user space. So maybe we should take that approach and just build the thing in NV list and then pick whichever converters we want. I think the existing one is probably fine.
Yeah, Umer is going to push draft patch at some point to see schemas and other things by user space soon, just for people to comment on those. Just he says he already implemented it for all relevant ZFS commands, but now looking on zpool ones like status, get, and so on. So expect soon there will be draft for that.
Be good to have an agreed upon schema on how we represent the data.
Because the other thing obviously is we should put a version number in the schema so that we can change it if we have to.
Yeah.
Obviously, we want to avoid doing that,
but sure, Don, please contact Umer just even before he pushed anything if you have any thoughts, comments. He's working on it right now.
Okay. Yeah, I don't think there's any issues, that would come up with picking one or the other. We already have an existing one, so maybe we can just augment that if necessary, and pull it into module common so that both user space and kernel can use it.
Yeah, I think also having status same way reported through zpool status versus procfs would be nice. Maybe not required, but can it be the same schema? Would it be difficult?
Same schema would be nice there, I suppose.
I don't see why they'd have to be different schemas. I mean, it's just that's just the endpoint. It's different, but should be the same otherwise.
I just guess it's taken from different places, potentially from several places, whether both sides have identical set of data.
Yeah, the tricky part is that you have to translate some of they're just enums, and so you have to give them string values. So that we should probably unify that.
Yeah, and user space has a bit more of a bunch of that for especially around scrub status and so on, where
it's all hard coded. So maybe we could
in the user space side.
Maybe we can make a facility that does those translations for us that they both can share.
Okay. Were there any other topics that people wanted to cover? We're getting close to the end of time. No. All right then. I think that's it for this month. Thanks everyone. And the next meeting is in 4 weeks, so that's May 21st at the usual later time. So 3 hours later than this week. Or 4 hours later? 4 hours later than this week. Okay. Thanks, everyone.